Okay, so I'm just gonna do kind of every problem just in order. I'm not gonna like jump around, looking for the answers. Um, just go one at a time. Okay, the first page I'm gonna do kind of like we did in class, where I'll call f the outside function and g the inside function, and then use the formula for chain rule, and then just substitute. Okay, so most important thing, chain rule. If you're taking the derivative of f of g of x, okay, so f is like the outside function. This is when, this is taking derivative of composite functions. So f is the function on the outside, and g is plugged into f, the function on the inside. Okay, so you're always going to take the derivative of the outside function, whatever that is, and then leave that inside function inside. Okay, and then multiply that by the derivative of that inside function. Okay, so that's going to be the rule. We're going to use that for every single problem where there's a chain rule. And I'll go through it step by step on the first page, and then I'll kind of do it kind of a quicker way on the second page, and you can figure out which way you like better. So, okay. For the first one, no chain rule. It's kind of just, I guess, a little warm up. So there's no, notice there's something squared and it's just x. There's a trig function and it's of just x. So that's not a chain rule. If it's just x inside the function, then technically that you could call it a chain rule, but it's not really, since the derivative inside is 1. So we're just really gonna just take derivative. So derivative of x squared is 2x. Derivative of cosine is negative sine. That's it. Okay, so next one. Okay, no chain rule for this one, since it's just tan of x. So this is kind of a mix of product, quotient, and tan. So this first one, just take derivative of tan. So the derivative of tan is secant squared. Okay, and they want the second derivative. Okay, so remember when you have a trig function squared or cubed or something, to an exponent, and it's written in this notation? You don't have to rewrite it, but you at least have to think of it this way. This is really like secant x, the whole thing squared. Okay, so now we're going to do a chain rule for this one. So we'll say the outside, or well, let's do the inside function first. So the inside function is, we'll just call it g of x, but we'll just call it g. So g is secant. Okay, so that's plugged into. So if you're not sure, so whatever the inside function is, just make that whole thing x, and that's the outside function. So since this is secant squared, make the whole secant, or just make that whole secant just x, so this is x squared. Okay, so you can see if you substituted secant into x squared, you'd get secant squared. So that's just a composition. Okay. So now we'll do f prime, which is 2x, and g prime, which is derivative of secant, is secant tangent. Secant x, tangent x. Okay, so now we're going to follow the formula for, let me grab that. So derivative, so f of g of x, the derivative is f prime of g times g prime. Okay, so first we're going to find f prime of g, so we're going to plug g into f prime. Take this g, plug it into f prime. Just, you know, all that means when you plug something into a function, you just substitute it wherever you see an x. So wherever you see an x in f prime, you're going to replace it with a secant. So this is going to be just 2 secant. And then times just derivative of g, right? G of x. Okay, so you could leave it like that. Definitely, if this was a for response, you'd leave it like that for sure. Multiple choice, it's going to be written most likely this way. Probably 2 secant squared x times tan x. Or it could be written as 2 times sine x over cosine cubed x. They might do that just to be tricky. Right, these secants are all 1 over cosine, and this tan is sine over cosine, so you've got like 3 cosines in the bottom and a sine in the top. Okay, so they'll probably be like that if it's multiple choice, 2 secant squared tan, but it could be that. Okay, so instantaneous rate of change is just derivative. Okay, so find derivative. Okay, this is a chain rule because you have something to an exponent other than just x. Okay, so our inside function, we'll do that first, is 2 plus cosine x. So our outside function, so make this whole 2 plus cosine x just an x, so this is just x cubed. Okay, then we'll take derivatives. Okay. So derivative of x cubed is 3x squared. G, the 2 goes away. And that's just negative sine x. Okay, now we'll follow the pattern, or the formula for f g of x. If you take derivative, that's f prime of g times g prime. Okay, just kind of being repetitive just to help remember. Okay, so now so this is saying plug g into f prime. Substitute this g into f prime, and for that x, so instead of 3x squared, right, f prime is 3x squared, but we'll really plug in that 2 plus cosine x. Right, and then just on the outside, we'll multiply it by g prime, which is negative sine x. Okay, if it was multiple choice, it would definitely be this. It would definitely be negative 3 sine x, like that. Okay, and that, you know, the ones I'm simplifying for multiple choice are really probably simplifying how they'll do it in this worksheet. So it must be on a different page. Okay, so next one. So next one we want to find second derivative. Okay, so first derivative. Okay, so this one, no chain rule, since it's just an x cubed. And this is just an x in a trig function. So no chain rule for this one. So derivative x cubed. Derivative sine. Okay, we'll take second derivative, derivative 3x squared, 6x, derivative cosine is negative sine. Okay, so that's it. Okay, next one for, for no matter what you're doing, whether you're doing product, quotient, chain, no matter what, you always have to change roots to fractional exponents. Okay, so this is chain rule because it's a trig function of something other than x, root x. Okay, so the inside function, the thing inside the trig function, is x to the 1/2. That'll be our inside function. Okay, and if you call this whole thing x, this is really sine x, so that's the outside function. Okay, and we'll take derivatives. Okay, so now derivative of the whole thing, and then notice, don't get confused, like these f's have nothing to do with this f here. I'm kind of always calling f and g the outside and inside function, no matter what this is here. Okay, so f prime will be g plugged into f prime. So this will be cosine of x to the 1/2 times, and then the derivative g. Definitely if this was for response, it would be that. Multiple choice, they'll probably do a couple of things. They'll change this to a root x, and this is 1/root x. And they'll probably write it all as one fraction. So tell me if this will make sense. So we'll make a fraction. Okay, the cosine of root x will be in the top. And then that 2 is in the bottom, so that'll stay in the bottom. And then this is a root x in the bottom since it has a negative exponent. So multiple choice, so it'll probably look like that, or on this worksheet it'll probably look like that. Okay, another one will change roots to exponents, fractional exponents. Okay, so we have something to an exponent other than x, so that we can recognize that as that we're going to use the chain rule. Okay, so the inside function, definitely sine is inside of something to the 1/2. So the inside function is sine. Means the outside function, call this whole sine of x just x, so this is x to the 1/2. So that's the outside. Derivatives. Okay, we'll follow the rule. Okay, so we'll plug g into f prime. So basically just rewrite f prime, no matter what it looks like, but we'll just replace this x with sine x. Alright, so notice that's just this is that, but instead of x, we'll write sine x. Okay, and then times that by the derivative g, which is cosine x. Okay, if if it was multiple choice or on this worksheet, this cosine will be in the top, this 2 will stay in the bottom. If we write this all as one fraction, and then this whole sign will be in the bottom, but as like a root sign, square root of sign in the bottom. So I'll have one fraction, 2 stays on the bottom from the 1/2, cosine will be in the top, and then that square root of sign will be in the bottom. Okay, next one, no chain rule because it's just x squared and just cosine x, you know, just an x inside a trig function or x being raised to an exponent. Okay, so no, yeah, so no chain rule for this one. So this will just be a product rule, right? Two functions of x that are multiplied. So this is just a product rule. Okay, so we'll do derivative. You know, if this is the x squared is the first function, cosine x is the second function. Okay, we'll take derivative of the first and then times the second. Derivative of that one and just times that one. Okay, and then we'll keep the first one the same and then times the derivative of the second one. That the same, take the derivative of that. Okay, for response, just leave it. Whatever you get that first line, just leave it. If it was multiple choice, they'll do probably okay, and then they might actually pull out an x, but so a free response could be either one of these. Okay, next one. So the definitely chain rule, right? You have a trig function of something other than x, here at x squared. Okay, so that x squared is going to be the inside function. So we'll call that's g. And the outside function will be cosine x. Okay, take derivatives. And the formula for chain rule says you plug g into f prime. So replace this x and f prime with g with x squared. And then just times that by g prime. Response that will definitely look like this, no question. May have parentheses with the x squared, might not, but besides that it'll be like that. Alright, so that's the first page. What was that, 20 minutes? Okay, second page. Okay, no chain rule, because you just have an x to an exponent and just a trig function of x. So this is just kind of a normal derivative, power rule, derivative of sine, it's cosine. So that's it. So remember, you don't have to, whenever you see like the exponent with the trig function, cosine cubed or cosine squared or something like that, you don't have to rewrite it, but you have to think of it like this at least. Those mean the same thing. This is just a notation. That's the way that they choose to write it. They could easily just write it like this. It means the same thing. And if you're in the if you're putting this into the calculator, if you're evaluating at some x value, you would have to write it like this. So okay, so definitely a chain rule. Once we come to the derivative 2 is just going to be 0, so that'll go away. But once we're taking the derivative of cosine cubed, definitely cosine's the inside function in the chain rule, right? Something other than x to an exponent means that we're going to have a chain rule. So then the inside will be cosine. Okay, make that cosine just an x. That'll tell you what the outside function is, which is x cubed. We'll take derivatives. Okay, then we'll follow the formula. Oh, I was going to do the second page. Okay, I'm going to do some of these the quicker way. I'll start with the next chain rule one. Do it the quicker way. Okay. So let's go to derivative. Okay, derivative 2 is 0, so that just goes away. And then we'll do f prime with g plugged in. Okay, so instead of 3x squared, it's 3 cosine squared. Cosine x squared. And then times g prime. Okay, multiple choice will look like they'll pull the negative out with the constant. They'll usually write the squared function last, I think. Let's see. That's definitely how they usually do it. But they could write the squared function first. Okay. Actually, I'm going to do this one the normal way. This has 2 chain rules. Actually, first, let's rewrite this since we have a trig function with an exponent. Okay, I'm going to use brackets so that we don't confuse it with the other parentheses. Okay, so that's what this square means really the whole thing is squared. Okay, so notice we have 2 chain rules because we have something other than x to an exponent, and then also something other than x inside of a trig function. Okay, so I'm going to do this kind of the okay, hopefully I have room, but we'll do this yeah, with the chain rule, but we'll have 2 chain rules, so we'll do this kind of a certain way. Alright, so overall, the inside function is sine of 2x minus 3. Okay, which means the outside, just call this whole thing x, so it's x squared is the outside. Okay, we'll take derivatives. Okay, and then notice we have another chain rule. So when we're taking the derivative, for the chain rule, you have to take derivative of the outside and the inside, and the inside function might have a chain rule. The outside function will never have a chain rule to it, but the inside function might itself have an inside, so that's another chain rule. Technically, you could have 3 chain rules. I think we had 1 in class, but we kind of did it a quicker way because it was an exponential. But so here, so I'm going to do like another chain rule with this one. Okay, so I'm going to just keep calling these F and G. They're really just the inside. Whenever you see an F, that's the outside, G is the inside. Okay, so the inside in this case for this problem is 2x minus 3. And then the outside will be sine x. If you take derivatives, okay, and then we'll plug g into f prime. Okay, and so now this is our overall original chain rule. So we'll do that. We do chain rule for that. We'll plug g into f prime. Okay, that's plugging g into f prime, and then times that by g prime. Okay, so, definitely leave it like this for your response always. For multiple choice, they could be tricky. I don't know if you remember the double angle formula for sine. So like 2, just in general, the identity for 2 sine x cosine x is sine 2x. So they're saying if you see a 2 sine cosine, here we have a 2 sine cosine, this identity says you can rewrite it as sine as twice sine of twice the angle. So these are kind of relative to each other. If these are x's, then the identity you'll change it to a 2x, to twice that. So we could write it as, and I don't know what the answer is in this worksheet, but it'll be like just sine, could be sine of 2 times the angle, which is really 4x minus 6. Right? If whatever these things are inside of whatever these angles or whatever are inside of sine and cosine, just double that. So whatever these are, you double that in your answer. Okay, so that could be a little kind of tricky way to write. But it's definitely a more simplified way, so it makes sense that someone might write it like that as an answer. So, and if you were solving an equation that involved this expression, equal to something, you would have to change it to this. So it makes sense to ask people to change it to that, I think. Okay, next one. You don't have to rewrite it like this, but I'm going to rewrite it just to emphasize that this needs to be the way that people are thinking about this. It's like 1/2 x. Okay, I'm going to do the rest of these the quick way. Okay, quick way is kind of noticing you have an outside function, you have an inside function, which is a 1/2 x. So definitely chain rule because you have something other than x inside of a trig function. The inside is a 1/2 x and the outside is tan x. So just right away, take the derivative of the outside function. So derivative of tan is secant squared. But instead of writing secant squared of x, you'll write secant squared and you'll keep the inside in there. And then just on the outside times by the derivative of the inside. So derivative of 1/2 x is just 1/2, and that's it. So notice you don't, it's good to be organized and, especially at the beginning to keep everything straight. But, up to you. You can do it however you want ultimately. Keep doing it with the F and G thing. So it makes no difference. Okay, multiple choice would probably be that. This half might just be pulled out to the outside also, instead of making a fraction like that. Okay, so just making sure everyone knows that sine cubed x is really sine x cubed. write parentheses just to emphasize that's the inside. Okay, so definitely overall product rule. We have two functions of x multiplied. Okay, so let's start taking derivative with product rule. Okay, so we'll take derivative of the first, but notice this function, this sine x cubed, is definitely a chain rule because you have something other than x to an exponent. So I'm going to do chain rule, but I'm going to do the quick way. So the outside function is x cubed, so that's like 3x squared. And then you keep the inside function alone. Just rewrite the inside function, don't take the derivative in the first step. And then times that by the derivative of the inside, which is cosine x. Okay, so this whole first thing, don't forget we're doing the product rule. This whole first thing is just the derivative of the first function when we're doing the product rule, so we still have to times it by the second function. Okay, then we'll do plus. So notice, yeah. And then now we'll rewrite the first function. And then, so just rewrite that, and then times by the derivative of the second function. So we have a chain rule because there's something other than x inside of the trig function. Okay, so the quick way, just take the derivative of the outside function, so derivative tan is secant squared, leave the inside function alone. If it was 3x before, it's going to be 3x in the first step, and then times that by the derivative of the inside. So derivative of 3x, the inside function, is just 3. Okay, for a free response, definitely final answer. Okay, probably, assuming that they don't pull out a, they could pull out a sine squared at least. They could pull out a 3. They could even pull out a cosine, 1 over cosine squared. I don't know. You can do a lot of things. Yeah, okay. So I'll do just rewrite these, just kind of simplify. So this will be like, actually I don't know the best way to do this. I'll just leave it like that. There's a ton of ways to do this. We'll just leave it like that though. Okay, so overall quotient rule. Okay, notice in the quotient rule at different points we'll be taking the derivative of the top and bottom at different points. Derivative of the top does not have a chain rule because it's just x to an exponent. And the bottom doesn't have a chain rule either because trig function is just of x. Okay, so let's do the quotient rule. Okay, always start off by taking derivative of the top and then just times that by the bottom, and then minus the top, and then times derivative of the bottom, and then all over the bottom squared. That's probably it. You know, they can factor out an x from the top, but besides that, yeah, that's probably it. So I'm just gonna leave that one also. That would probably be the multiple choice answer. Okay, next one, they want us to do second derivative, but we're gonna be smart. So this is cosine x times sine over cosine. So before we take derivative, so this notation is second derivative. We're going to change tan to sine over cosine. And then these cosines cancel out, and we're just taking derivative of sine. Oops, not equals. Cancel, and just taking derivative of sine, or second derivative. Okay, so the let's do it like this. Okay, so second derivative, so first derivative, let's say dx, first derivative of sine is cosine. So I'm kind of just using this notation also. Okay, and then the second derivative will be the derivative of the first derivative. Second derivative is just the derivative of the first derivative, which is negative sine. Okay, so no chain rule because you had a trig function. The inside the trig functions were just an x. Wow, last one. Okay, so let's rewrite this. Roots. Right as fractional exponents. And then that sine, you don't have to rewrite it, but just remember that's sine x squared. Sine squared x is sine x squared. Okay, so definitely two chain rules, because we have this inside, we have something other than x to an exponent, this inside function, and then the inside function itself has a term where you have something other than x to an exponent, in this case sine x. Okay, so but I'm going to do this the quick way. Okay, so the overall outside function is just x to the 1/2. So we're taking derivative of that, that'll just be 1/2 and then something to the negative 1/2, you know. But we're going to keep the inside function exactly how it's written in the first step. Okay, now we're going to times this by the derivative of the inside function. So now we're just focusing on the inside, and that's what gets multiplied on the outside here. Okay, when we take derivative of the inside, that 1 will just go away. And then we're taking the derivative of sine x squared. Okay, when you do that, the derivative of the outside is just something squared. So that'll be 2 times something, you know, technically to the first. But we don't have to write that. Okay, and the inside function is sine, so that stays on the inside in the first step. And then times that by the derivative of the inside. Whoops. Wait, what? That was weird. Oh yeah, never mind, sorry. And then derivative of the inside, derivative of sine is cosine. Okay. Okay, so definitely that's the answer. If it was free response. Okay, on this worksheet, we're on multiple choice. This will make a fraction. Since you have a negative exponent, we'll almost always make a fraction. Definitely this term will just be a square root of 1 plus sine squared in the bottom of the fraction, and then this 2 will be in the bottom also. Oh no, the 2's cancel. So sorry, that 2 will cancel out with that 2, so definitely forget about that. And then this sine and cosine will stay in the top of the fraction, since those don't have negative exponents. And then we'll change that to that notation of sine squared x. So that could be almost definitely the free response, or the multiple choice.